Swayam Prabha. Digital India. Educated India.
Welcome back to infrared spectroscopy. We're going to talk about NH bonds. We talked about OH bonds, CH bonds. Now it's time to talk about NH bonds. Okay, let's look at NH bonds and where do we find NH bonds? Typically amines and amides. That's where you have NH bonds and amines and amides. These are two spectra of amines. So amines are primary amines, secondary amines, and tertiary amines. So this is a primary amine. That means the nitrogen would have two hydrogens attached to it and then an R group. The R group can be alkyl, aryl, whatever. Okay. Secondary amine is when you have the nitrogen attached to one hydrogen and then you can have different R groups here. And they need not be the same R groups, they can be different. Tertiary amine, and I'm just only going to have just a little note about it. There's really not much to say about tertiary amines because IR infrared spectroscopy is not really very useful for tertiary amines. Let's look at primary amines, see what these are. Well, you immediately recognize the CH peaks and the CH bends, right? That's so that means it's an alkylamine. You don't see anything really in the sp2-CH region, so it's probably an aliphatic amine. That means there's no double bonds and stuff. So we can kind of account for these peaks and these. But what about these? What do they mean? Let's look at one of these. Just let's sweep just like the infrared machine from left to right and see what all these things are. First of all, two very prominent peaks. They're not strong in the sense that they don't come all the way down here. They're kind of medium, all right? And that's two peaks, and you know it's in a very high region, so most probably it's attached to hydrogens because the mass goes down, the wave number goes up. So these are CHs, these probably are NHs, and they are NH bonds, and you can do the same calculation and figure it out, and those would be where they are. And you have two of them. Why? Because you have two NHs. You can have symmetric stretch and asymmetric stretch. So therefore, these peaks are NHH. Asymmetric is typically the higher, and then the other one here would be your symmetric stretch. And that's typically around 3500 to 3300 range. And that's where we see a doublet or a double peak. This is for an aliphatic, okay? That means it's just like an alkane attached here. Let's say if it is an aryl amine, aromatic amine, like an aniline, it will be stronger and it will be coming down a little bit more. Stronger, around 3400, you'll get two peaks. All right, so the NH peaks here are typically medium or even sometimes weak. Aromatic would be medium to strong. Now, well, let's look at the other peaks here. What's this one and this one and this one? Over here, we are going to have a peak here for your NH bend, NH scissoring bend. And that's pretty, it's medium. It's about 1640 to 1560, and it's quite, it's medium, but tends to be a little broad and medium. So that's something that you would always see with a primary amine. You see a peak right here. And sometimes if you have benzene rings, that kind of is the same region as the CC double bond of the benzene ring. And you see that this is going to be a little broader, whereas the benzene CC would be narrow. Now, when we go down here, we do see a CN stretch. You know, CO stretches are also in this region. You would see a CN stretch, and the CN stretch is in the region about 1350 to 1000, and that's this. All right. Sorry, we have to go all the way around. So this is also different for aliphatic and aromatic. Aliphatic CN stretch would be about 12,000 to 1250, and the aromatic is going to be a little higher than that, 1250 to 1350. So that's one of the other ways that we know that this is an amine. Now we do see a very large peak here, and this is about 800. Around 800 you have NH out of plane band. Okay, and that seems to be in a very, it's about here. Okay. So here's our NH out of plane band, and this is about where it is. Okay. All right, so we kind of accounted for most of the peaks here on a primary amine. The most important peaks that we look for in a primary amine is a double spiked peak here in the 3400 around, and a peak here around 1600, NH bend and NH stretch. Those are the characteristic peaks for a primary amine. Let's go over now to a secondary amine. They're very similar, except you can see immediately that this is a single spike. That's because you only have one NH, so you have a single spike. This has got two, so you have a double spike there. So this is going to be your NH stretch here, and it's typically weak. Okay, at most it could be medium, but it's a weak peak, and it could be kind of broad too. Okay, at the top, and then it kind of tapers into a tiny little spike here, but the top could be broad. Now again, these are, you know, your dear friends, your aliphatic CH and CC bonds, CH bends, CH stretches. Those are really very prominent. Then you again see these two peaks here. So this one around 12 to 1200, you can see something here. That is going to be your NH. Over here, it's going to be your CN stretch. Okay, now we did see an NH scissoring bend 1640 around, and you can see that there is one here as well. So you would have an NH scissoring bend here too, around 1500 here. So this is about 1500, so you can see that this is going to be your NH scissoring bend. All right, so here's your scissoring bend, and here this one is going to be your CN stretch around 1100. That is your CN stretch, and a very broad peak here, and that is again your NH out of plane bend. So those are some of the, you know, really important peaks. All right, so very briefly, a summary here. For primary amines, you'll have a double spike, and that is due to the symmetric and asymmetric stretches of the NH. You'd have a broad NH bend here, scissoring bend here, around 1600, and then you'd have a CN stretch around between 1000 and 1350. Typically, if it's aliphatic, it's going to be closer to the 1000 range, and if it's aromatic, it's going to be closer to the 1200 range. You have a very broad peak here for your NH out of plane bend. Secondary amines, when you compare, only one spike here. These are typically medium. They don't come all the way down here. They're somewhere usually up here, and there's only one spike. And if you go down here, 1500 around is your NH scissoring bend, and so you can see it over around here. Now the CN stretch is around 1100, and the out of plane NH is around 700. Okay, so these are some of the things that you're going to look for when you have a nitrogen-hydrogen bond in your formula. All right, let's come back and compare these with amides. So we can have all 4 of them and see what the main differences are between amines and amides. All right, hold on, folks. Hold on to your seats. We'll be right back with your amide spectra to compare these two. Thank you. Welcome everybody, welcome to infrared spectra. We're going to talk about amides today. Amides are a very important functional group because that's pretty much our backbone. All our proteins are amides. So it kind of makes amides a very central functional group for biochemists. So let's look at amides here. Well, there are 3 types: primary, secondary, and tertiary amides. Okay, I have here primary and secondary because they have NH bonds, and NH bonds, just because you are connected to a hydrogen which is really teeny, the mass goes down, the wave number goes up, so you see them in this very high region. And let's try to filter out all the things that we don't have to look at, which is all the alkyl hydrogens, alkyl part. So this is your alkyl. So this is an, we know that this is due to your alkane and this one. Let's look at what these could mean then if you have a primary amide. A primary amide, as you know, would have 2 hydrogens connected to a carbonyl. 2 hydrogens on the nitrogen connected to a carbonyl. So you should be able to see over here symmetric stretch, asymmetric stretch, which is what you see here. So this is your NH stretch, and NH stretch you would have 2 of them, and they would always be very strong when you have an amide. Amides also have a very strong resonance compared to other derivatives of carboxylic acid. Amides, of all of them, amides actually have the strongest resonance. So that's something to keep in mind. These NH bonds, the polarity is strong, therefore the intensity is really high compared to amines. Now if you have amines, they'll be really teeny in here. So for the NH stretched, there'll be 2, again asymmetric and symmetric, and they would be, one would be a higher intensity, 3475 around, and the other one would be about 3150. So you would have a double peak. Now, we know these are CHs, let's move on. We have in this region, and you know this is the central region of the spectra, the most important peak that can happen around here is the carbonyl stretch. And so let's look at that here. Your carbonyl stretch is going to be this peak over here. This one, okay? That's about the CO stretch of your carbonyl, of your amide. So I'm just going to put R here. So that is going to be a CO stretch. And because you have it conjugated in a way with this nitrogen, you're going to have lowering of your wave number. We saw earlier, whenever you have conjugation, your wave number goes down, okay? So therefore, you are now looking at something around 1680, not even in the 1700, it's dropped below 1700, and it's about 1680 to about 1630 centimeter. That's the range, depending on what all is on the molecule. So that CO stretch is typically the most prominent. Here you see that it's almost like a doublet. What is the other peak here? So here are some other peaks. Let's see what these could be. Well, you can see that this is almost like a doublet peak, like two peaks in one. One of them is the CO, and the other one is the NH. So this is going to be an NH bend. Okay, we saw some CH bends here. This is an NH bend, all right? So the NH bend is typically around 1640 to about 1550, which is really close here to the CO. So that's why they appear right next to each other. Now you also have around 1125, which is this peak, kind of a weak NH bend. We have we have these NHs. This will be typically a weak NH bend. This is typically a strong NH bend. Now we also have a very wide peak here, and that is an out of plane bend for the NH. So here's an NH out of plane bend. So this is going to go, so this is the plane of the molecule, and it's going to go out of plane. And that's about 600 to 750. And that's what you see here. Okay, so we kind of looked at what all these peaks could be for a primary. All right, let's compare a primary with a secondary. What's the difference? We know secondary amides are only going to have one NH. They'll have an R group on this side, and they'll have a carbonyl with another R group on this side. So you only have one NH stretch, and you only see one peak. You don't see a double peak. But again, this is also going to be pretty intense. Amides, as we said, have a lot of resonance. This is going to be a more important resonance structure, but you have a teeny bit of ionic charge separation. It's not an ionic compound, it's a neutral compound, but you can have some charge separation, which increases the dipole moment on this molecule. And so therefore those NH bonds are very polar, and you can see they're pretty intense. So this is going to be for your NH stretch. So the NH stretch is going to be around about in the region 3300 centimeter minus 1. The rest of the spectra, I mean, this does look like it has a lot of peaks, and over here, this is probably due to an alkane. So you can see we can take that out, filter this out, then we can see the rest is pretty much NH bends and so on. All right, so again, we have a very strong peak around about 1680 really, and that is going to be a CO stretch. That's right. So CO stretch is always the most intense peak in IR spectrum, about 1680 to 1630. And also you can see that there is a NH bend that's going to be pretty strong around 1550 for secondary, for amides in general. So that's a very important peak here. In addition, you can have NH out of plane loop and other CN stretches and so on. So you also can have NH out of plane bends, and those are going to be 600 to 750 somewhere here. So these are really very important NH bends out of plane. But typically if it's an amide, you just look at this and this. If it's just a one spike here, that's a secondary. If you have two spikes here and they're really strong, it's primary. It has to be accompanied by a strong peak, less than 1700, 1650 to 1700 range here. 1680 around is typically the number that you see for that. These are the fingerprint region, but it's useful to have these to identify some of the functional groups, but we mainly look at these peaks for amides. All right. We will see you soon with a comparison of amides and amines. Hello everybody, I just want to do one more thing with NH bonds before we finish. I want to compare the NH bonds of amines with amides. They're all NH bonds, but there are lots of subtle differences and maybe some obvious differences. And let's look at how you can differentiate between amines and amides. Okay, you have a sample and you want to run an IR to see what the functional group is. This is the perfect thing to do. All right, let's look at the primary amine versus primary amide. What's the first thing that strikes you? Right, these are really big and these are medium. Okay, so that's one of the very obvious things. There's a little shoulder here. That's just a overtone of the NH bend here. So, but these two peaks are the symmetric and asymmetric stretches here. So one of the main things is this one is got medium NH stretch, and this one has got very strong NH stretch. This NH is in resonance with the carbonyl next to it, and so that's the first difference. NH stretch medium. That means it's kind of doesn't come all the way down, somewhere in the middle. Here the NH stretch is strong. Now, if you had an aromatic amine, it might go a little down here, a little bit more, okay, because that's also in conjugation with the ring. Another very important difference that you would notice is right in the middle of the spectra, this one's got something that's coming all the way down here, whereas here, this one's got a teeny peak up here. So what's the difference? This peak here is completely missing in this spectra. This is your carbonyl peak, okay? So CO peak only in amides, right? Because your amides got CONH2 and your amine just as RNH2. So here you don't have that. Let's look at another difference here. The NH here is typically broad and medium, okay? So NH medium. It doesn't come all the way down. And it's broad. The NH peak here is very strong. You can see it comes all the way down here. So NH bend, this is a bend, scissoring bend, is strong, and it is also tapered, narrow. Those are the main things. I mean, we don't really look at the outer plane NH bend and compare. We typically use this to differentiate between the primary amine and the secondary amine. And you know that these peaks are your CH peaks, and we've seen that before. So just, you know, to bring that to mind, I'll just put that up. So there's your CH peak over there, and here's your CH peak bends and stretches. So you really don't have to worry about them. We do have CN, single bond stretch, NH, outer plane loop, but we don't use that. That's typically the fingerprint region. We don't use that for comparison to see if it's a primary or secondary. These are the main peaks that we use for the comparison. It's going to be the exact same thing over here. The NH bond here is NH stretch, you can see, is weak. Can go weak to medium. It kind of starts out broad and there's a tiny spike here. So this is your NH stretch, and that's going to be weak to medium. Okay, at most medium, but typically it's weak. All right. Whereas over here you can see the NH is coming all the way down. This little spike here is an NH bend overtone. So that's going to be a very strong NH stretch, just like over here. NH stretch is very strong. So these we know are alkyl peaks, and you know, we can look at them again. If you do this, we don't have to worry about this and this, because those wave numbers are due to your alkyl groups. Let's move on from this region over to the middle region. You can see that these peaks are missing here, which is basically your carbonyl peak, because secondary amides would have a CO double bond stretch because they have an NH here and some R group. So that is going to be your CO stretch, which you will not have here. There'll be a gap in here, so that's kind of pretty obvious that this is not an amide and this is an amide. Now you can see that you have a very strong NH bend here and NH bend here around 1550 is a little bit further to the right here. This is the fingerprint region. So this is the main region that we use to compare whether it's a amide or an amine. So if you look at all of these spectra over time, if you look at many of them, it becomes more and more obvious what to look for to identify a functional group. So these are primary and secondary. What about tertiary? We never talked about tertiary. Why don't we ever mention it? So let's compare tertiary amines and tertiary amides. Well, if you look at both of them, they're not going to have any NH. So this region is going to be completely absent in both of them. No NH stretch. no NH bends. So there's really not much to look at there. You can do a CN stretch. So they would have a CN stretch, and that's going to be around 1050, so that's the only way. I mean, so it's really not very useful for tertiary amines. Tertiary amides, you're still going to have 2 R groups here, and you won't have, any NH groups, so there won't be any of this. There won't be any NH bends, but you would have a carbonyl, and the carbonyl would be towards 1680 around and below. And then you would have a CN just like here. CN is going to be a little bit higher than that, probably around 1100 to about 1250. You'd have a CN for an amide. Okay, so those are some of the things that you would see on a tertiary amide. Well, infrared's becoming more and more important, because when you set up the James Webb telescope, that's the main difference between Hubble and James Webb telescope. The James Webb telescope is going to get information using infrared. So all the things that you cannot see, you can see, and all of the heat waves that you can, is below the red light, is going to come in, and then they're going to take that, process that, and see, translate that using computational methods to a visible model. Okay, so now we have like things like eyes, infrared eyes. They can see things out there that our visual eyes cannot see, or we cannot see in the visual range. So this is a huge breakthrough, and we're seeing a lot more planets and galaxies out there using infrared. Okay, so that's another huge application of infrared, not just on, to find things here on this planet, but also other planets like carbon dioxide, ammonia, water. I mean, these are things that are giving us information as to whether there could be life out there. All right, so let's come back, and we will kind of summarize with some of the functional groups that we looked at and see how they compare. All right, talk to you soon, guys. If you have any questions, let me know. Bye.